Right, so today we're going to start section 7.1. In chapter 7, what we're going to start with in this first section and partway into the next section is talking a little bit about some definitions. We're going to talk about surveys. We're going to talk about some other different things which then are going to lead us into kind of our main topics in section 7.3 and 7.4. So if we go back and we think about chapters 2 and 3, we learned about data summary techniques. In chapter 5, we learned about probability. And in chapter 6, we learned about normal distribution. In this chapter, we're going to combine some of those ideas from all of those different chapters and learn about surveys, make inferences based on those surveys, and measure how reliable those predictions may be. All right, so our first definition here should hopefully look familiar. So our first definition is that of a population. A population is a group of objects or people that we want to study. When we're thinking about the word population, the key word that we want to think about is all. Right? So it is all of the people in a particular group. It is a larger group that we are drawing from. Right? So that's going to be our population. A numerical value that's associated with our population is called a parameter. A parameter is a numerical value that characterizes some aspects of the population. Parameters include our population mean, our population standard deviation, and our population proportion. A census is a survey in which we measure every member of a population. Unfortunately, those are generally difficult to do. So a lot of times, some of the things that we're going to be doing is we're going to be making estimations about our populations based on the definition that's at the bottom. So if we see the word population or parameter, again, we're thinking all, our entire group of objects or people that we want to study. So in example 1, data is gathered on the heights of all NBA basketball players. The mean of the data is calculated to determine the population and the parameter. All right, so we see the word all here. So our population is all NBA basketball players. Right, and the parameter is the numerical value that we're talking about. Our numerical value that we see here is the mean. So the parameter is the mean height of all NBA basketball players. All right, so back in the beginning of the semester, when we talked about the word population, we introduced that with another word, which was our sample. Right? A sample is a collection of objects, right, or people taken from the population of interest. Most populations are too large for a census, so we study populations by measuring samples instead. And once we measure something with a sample, then we kind of use that to make a guess about what's happening in our population. So with population came the word parameter. With the word sample comes the word statistic. A statistic is a numerical value that characterizes some aspect of the sample. They include our sample mean, our sample standard deviation, and our sample proportion. Sometimes we refer to statistics as estimators because it is used to estimate the value of a parameter. So we use our statistics from our samples to estimate our parameters about our proportions. Right, so we're going to explore this vocabulary just a little bit more in these next couple of examples. A researcher is interested in studying the heights of American women. She takes a random sample of 1,500 American women and finds the mean height of the sample is 63.6 inches. Determine the sample, the statistic, and then what the researcher may estimate. Right, so the sample is the 1,500 American women. Right, the statistic is the sample mean of 63.6 inches. Right? The researcher may estimate that the average American woman is 63.6 inches tall. So we estimate about our entire population based on our statistic. All right, so let's work through one more example. In January 2015, the Pew Research Center published a report stating that 37% of Americans believed that genetically modified foods were safe to eat. This was based on a survey of 2,002 adults. Identify the population in the sample. What was the parameter of interest? What was the statistic? So our population, again, when we're thinking population, we're thinking about the word all. So our population is going to be all American adults. Right, the sample is the 2002 American adults surveyed. Right. Our parameter is the percentage of American adults because remember, parameter is a numeric value, so our parameter is our percentage of American adults who believe GMOs are safe to eat. Right, and our statistic is what we found in our sample. So in our sample, 37% of the sample who feel this way. Okay. So again, going through our vocabulary, again, population and parameter. Again, we're thinking all, we're thinking our entire group, and then sample and statistic, right, are just coming from a smaller portion out of our population. Right, so to kind of wrap this up, the definition down at the bottom is that of statistical inference. Parameters are hard to find. It's hard to collect data from our entire population. Statistics are much easier to find. Anytime we collect data from a sample, we can find the value of a statistic. So when we take these statistics and estimate for our parameters, that is something that we call statistical inference. Statistical inference is a science of drawing conclusions about a population parameter based on statistics from a sample. This does involve some degree of uncertainty because our entire population is not being measured. And then an important component of statistical inference is actually going to be measuring that uncertainty. So that's going to be something that we're going to end up talking about in the next couple of sections. Okay. So then to finish this off, up at the top we just have a reminder of our notation. So if we are thinking about a sample mean, we're using X bar. If we're thinking about a population mean, we're going to use mu. Sample standard deviation, we use S. Population standard deviation, we're going to use sigma. Sample proportion, a proportion is going to be a percentage. Right? A lot of times when we're looking at these. A sample proportion, we're going to have P with this little triangular part above it. We call that P hat. And a population proportion, we're just going to use the letter P to represent that. Right? So as we go through these next few sections, as we go through the next couple of chapters, notation is going to be something that we definitely want to pay attention with. So just keep this table in mind when we're thinking about our statistics versus our parameters and the correct notation for each.